Imagine an old lady claiming that the Earth is a plate placed on the back of a turtle, and underneath it are countless other turtles piled on top of each other. We laugh. But do we, tiny creatures on a fragile blue planet, really know more about the vast cosmic ocean that surrounds us? Let's embark on a journey to discover the deepest mysteries, from the chaotic origins to the great structures that we are a part of. Come dive with me into the abyss of the universe, where every speck of dust tells a story about the birth of all things. Welcome to our channel, where we will embark together on an intellectual adventure, exploring the greatest mysteries of the universe, the endless cosmic ocean that Carl Sagan once compared. Since ancient times, people have looked up at the night sky, longing to explain the sparkling lights and the magical cycles of celestial bodies. Our ancestors, in their immaturity of perception, attributed them to divine powers, governing human destiny. They watched the sun rise and set, the moon wax and wane, the four seasons rotate, and believed that these were messages from the invisible world, demanding respect and offerings. But deep within each of us is still the thirst for knowledge, the thirst to lift the veil of mystery. The history of science is a long, persistent journey to replace vague hypotheses with understanding based on observation and reasoning. Let's go back in time, to about 340 BC, when the Greek philosopher Aristotle made a convincing argument that the Earth was a sphere, not a flat disk, as many people mistakenly believed. He observed that the lunar eclipses, when the Earth's shadow falls on the moon, are always round, which could only be true if the Earth were a sphere. Furthermore, the fact that the North Star appears in different positions depending on the latitude of the observer also supported this argument. Aristotle believed that the Earth was the center of the universe and that other celestial bodies moved in perfect circular orbits around it. This idea, later developed by Ptolemy into a complete geocentric model of the universe, dominated human thinking for 1,500 years. The Ptolemaic model, although complicated with its epicycles to explain the apparent motions of the planets, was accepted by the Catholic Church as consistent with the Bible, allocating a place in the outermost heaven to the fixed stars. However, in 1543, a Polish priest named Nicholas Copernicus proposed a bold, much simpler hypothesis. The Sun was the center of the solar system, and the Earth and the other planets revolved around it. This idea, initially considered heretical, took nearly a century to gain widespread acceptance, thanks to people like Johannes Kepler, who improved upon Copernican theory by showing that planets moved in elliptical rather than circular orbits, and Galileo Galilei, who was the first to use a telescope to observe the heavens, discovering the moons orbiting Jupiter, proving that not all celestial bodies orbited the Earth. The final blow to geocentric theory came from Isaac Newton, whose Principia Mathematica was published in 1687. Newton not only formulated the law of universal gravitation, explaining that all bodies attract each other with a force inversely proportional to the square of the distance between them, but also developed a powerful mathematical tool to describe that motion. He showed that gravity keeps the moon orbiting the Earth and the planets orbiting the sun in elliptical orbits. Newton's conception put an end to the idea of a static, infinite universe. But scientists of the time, so accustomed to the idea of staticity, sought to modify Newton's theory by adding an anti-gravity force to balance the gravitational force. Even Albert Einstein, when he formulated his general theory of relativity in 1915, initially believed that the universe must be static, and he introduced a cosmological constant to balance the gravitational force. But all that changed in 1929, when astronomer Edwin Hubble made a landmark observation. Distant galaxies were moving away from us, and faster the further they were. This was evidence that the universe was expanding. This discovery brought the question of the beginning of the universe into the realm of science. If the universe is expanding, then things must have been closer together in the past. Hubble suggests that there must have been a moment, about 10 to 20 billion years ago, when all matter and energy was concentrated into an infinitesimal, infinitely dense point, a singularity we call the Big Bang. At this singularity, the laws of physics as we know them break down. Predictability is lost. Yet this event marks the beginning of time and space. We cannot look into space without looking back in time. Light from distant galaxies takes billions of years to reach us. When we look at a quasar 8 billion light-years away, we are looking at it 8 billion years ago, before the Earth was even formed. Our universe began as a uniform bright ball of fire, filled with matter and radiation. As the universe expanded, it cooled. About 1/100th of a second after the Big Bang, the temperature reached 100 billion degrees, and the universe was filled with photons, electrons, neutrinos, protons, and neutrons. About 3 minutes later, protons and neutrons began to combine, forming the nuclei of helium and heavy hydrogen atoms. Several 100,000 years later, when the temperature dropped to a few thousand degrees, electrons combined with nuclei, forming complete atoms. Radiation from this hot phase still exists today as the cosmic microwave background, CMB, discovered by accident in 1965 by Penzias and Wilson. The CMB is the golden evidence for the Big Bang. The expansion of the universe was not completely uniform. Small fluctuations in the density of matter from the early times, amplified by gravity, led to the formation of larger structures, galaxy clusters, galaxies, and stars. Our own galaxy, the Milky Way, is a giant spiral band containing hundreds of billions of stars, orbiting a massive center. These stars are like giant cosmic kitchens, where hydrogen is cooked into helium, and then heavier elements like carbon, oxygen, iron. These elements are the building blocks of planets and ourselves. Life as we know it depends on carbon and water, elements abundant in the universe. The life of stars is a grand symphony. From giant clouds of gas and dust, stars are born, burning for millions, even billions of years through nuclear fusion. When their fuel runs out, they end their lives in a variety of spectacular ways, becoming white dwarfs, neutron stars, or, in the case of larger stars, collapsing into black holes. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are great mysteries, the Cheshire cats of the universe, where information can be lost, defying the fundamental laws of physics. The existence of black holes, pulsars, quasars, quasi-stellar objects, possibly supermassive black holes at the centers of young galaxies, is evidence that the universe is filled with extreme, extraordinary phenomena. We are on the verge of a new era, where human intelligence, with the tools of science, is gradually revealing the deepest mysteries. We have gone from thinking that the Earth is the center of the universe to realizing that we are just a speck of dust in an infinite galaxy, and that galaxy is one of billions of others. This humility does not diminish the greatness of humanity, but rather increases the desire to understand and explore. The universe is not a static stage, but a living entity, constantly changing and evolving, where we are travelers on an endless voyage. Together we have traveled across the ocean of the universe, unraveling the secrets of its vastness, its chaotic origins, and its magnificent phenomena. From the first atoms to the magnificent galaxies, all obey a cosmic symphony of evolution. But how did life arise in this symphony? From simple organic molecules to complex multicellular organisms, and finally to our intelligent civilization. Was this process a miracle or an inevitable law? What conditions have driven this evolution, and what future awaits us in the ever-changing universe? In the next episode, we will dive deeper into the magical journey of the evolution of the universe, life, and civilization. Don't miss it.